Yes, now?
Yeah.
Once you figure out what's going on, it's really not that bad. But it's the figuring out what's going on that's tough. Um, $87. Okay. Yep. So, real estate agent has grabs something about 3 keys and 8 keys, right?
They have 8
master
homes.
keys.
Yeah.
Yeah. So 8 master keys, but only one's the right one, right?
Yeah, unique key for each house. 40% of the homes are left unlocked.
Yeah. Do you want to make it a he or a she?
It was she.
I mean, it has a great bearing on the problem, right? She grabs 3 keys at random. Yes, no?
Mm-hmm.
Also, 40% of the homes are left unlocked, which, depending on the community, doesn't give you exactly a warm fuzzy. But anyway, this is what we're given, right? What's the probability that she can get in? Yes, no?
Your bathroom fall down. Close. What?
This is basically the problem. I didn't copy it word for word, but this is it. Yes, no?
Can you turn your stream on?
Jeez. Yeah, I've been writing the for the past 5 minutes and wondering why you guys haven't really commented too much. Yeah. I didn't even get the blasted camera out yet. I blame it on Chris.
You're welcome.
He distracted me. The he, she. Are we even allowed to say that anymore? I don't know. So I was at Dollar General yesterday, right, on the way home. And there was this, there were a couple of the workers. It was pretty late at night, so they only had 2 staff on, which is normal for a suburban Dollar General. It was in LaGrange. LaGrange doesn't have any traffic lights in through LaGrange. Anyway, it's not a bad community. They got good people and not so good people. Wrong way. So anyway, both of the both the clerks were girls and all that, and so I was, I just noticed them, got what I needed. So I go up to the checkout thing, and one of them runs up, and
It's just in my coffee.
We are under a tornado warning. My wife just said. Towards where?
I'll be at George's house.
Congress, Westfield Center, Marshall. Okay, it's probably going to go to the south of us. Okay. Yeah, it's probably going to go to the south of us. Where? Creston, okay. Anyway, so person goes up to the cash register and in this deep bass voice, this what I thought was a gal starts ringing me up. I'm glad I didn't call her ma'am or him ma'am. She really looked like a very nice looking young lady. Or he, I guess. I don't know. Anyway, I was a bit surprised. Okay, so can you guys see, by the way?
Yes.
Okay. If I have to bail real quick, you guys understand why, right? I mean,
Yeah.
okay. All right. So, guys, here's the Venn diagram. So the sample space is, can she get into the house, right? Well, 40% are unlocked, right? Yes, no?
Yes.
And the other way that she can gain access is if she's got the right key. Do you guys see that?
Yeah.
This area over here is that it's locked, right? This area on the left is that it's unlocked. The right key, the event that she has the right key is the bottom, whatever it is. We haven't found that yet. And the top is that she doesn't. So, do you see that the she can get into the house? The event that she can get into the house equals the event that is unlocked union, right? She has the right key. Do you see that? Right? Uh-huh. Yeah. Yep. So, what's the probability she has the right key?
3 out of 8.
Okay. And so to solve this, the probability that she can get into the house equals 0.4. Yes, no? This is probability is unlocked. Yes, no?
Mm-hmm.
Plus 3/8 Yes, no?
Yes.
Minus the intersection of the two. Yes, no? This is going back to the definition of, or not the definition, but how to find the probability of the union. Right, exactly. So minus, now with independent events, and we didn't, I don't think we really talked about this. What can I get? Can I get rid of important dates, guys? Yes, no?
Yeah.
For independent events. A and B. The probability of A intersect B is simply probability of A times the probability of B, which is the multiplicative rule. Right? I guess we did talk about it, but not in these terms. Yes, no? Does this make sense? Think in terms of when we figured out how many Subway sandwiches you could buy. Right?
Yeah.
If A is the event that you get wheat bread, right? B is the event that you get ham. Well, A and B are independent, right? One doesn't affect the other. Yes, no?
Mm-hmm.
So do you see that we just have to multiply these two values? Right? And what's 4/10 of 3/8? Be 12 out of 80. Just 3 out of 20, right?
Yes.
So this is equal to 0.4 plus 3/8 is 0.775, I believe, minus 0.15, right? Is that right? What does this give you? 625. And I believe that's the correct answer. 5/8, right?
Yep.
When I first started using this textbook all those years ago, probably like 10 years ago or so, I ran across this problem because I assigned it, and I'm going, how in the world do you get that number? That's 5/8. How do you get 5/8 out of this? And then we talked about it in class, and I'm like, oh crap, yeah.
Yeah.
This is a misleading value, is it not? This equals 5/8, but it has nothing to do with the fact that there's, well, nothing directly due to the fact that there's 8 master keys, right?
Yes.
Because I kept trying to do it like 1 minus 3/8 or something like that. So is your question answered, Chris?
Yeah, I never subtracted the intersection.
Ah, so you
From
kept
the
getting
two.
775.
Yeah.
Well, there you go. Makes sense?
Yeah.
That's the important thing. Does it make sense? Okay. We're going to dive into chapter 3 stuff, okay? All right.
Okay.
Can I reboot the board?
Yeah.
If I'm rebooting the board, I wonder what the power on self-test routine is. Right?
Well,
That
who wrote
post.
it?
What, rebooting the board?
Yeah.
Well, it's not really software, right? I don't know. That's a good question, Brian. Okay, we got to start off with the dry stuff first, okay? For a given sample space S, a random variable that's one of the few times you'll see me write out random variable, okay? Is any rule that associates a number
Your board's getting really blurry.
Oh, I know why. All right, I forgot to fire up Logi. I might have to stop the stream to do that. Let me check. The camera's trying to autofocus when it really shouldn't. And I got to switch to a different marker, it looks like. Camera not available. Okay, I think I have to stop streaming real quick.
Okay.
So we do that. And then what do I have to do? Do it again. Logitech doesn't like to attach to a camera that's already streaming, evidently. I haven't found any workaround. Yes, it is available. All right, well, maybe it'll work. Let me know if it goes fuzzy again, guys, okay?
Okay.
If it does, then I'll probably have to stop Discord and get back in. Okay. Okay. So, sample space S, a random variable RV is any rule that associates a number with each outcome in the sample space. The domain is the sample space, right? You can't have anything outside the sample space being associated with the random variable because it's outside the sample space. It doesn't exist. And the range is the set of all real numbers. How do you draw the set of all real numbers? Don't they have a funky looking R?
I think it's like got a double bar on the left. Does that make sense? Yeah.
Really?
You might have to connect the top. I don't know, actually.
How do you guys want me to draw it? Because we're in college, we can do anything.
I want to see some calligraphy.
Is that Liam?
No, that was Brian.
So what the script are? You know what I'm gonna do? There. Now you guys can't make fun of me. Well, you can still make fun of me, but anyway. Okay. Guys, what are we doing? Well, you got the sample space, right? Let's make it incredibly easy. Heads or tails, right? It's a weighted coin, okay? Let's say Liam got a hold of the coin and, Liam's kind of a shifty character, okay? So he's going to weight the coin. Liam, which way are you going to weight the coin? Are you going to weight
Heads.
it heads? So
The
heads is over
will
here?
Show up more often. Yeah.
Heads
Yeah.
and tails, right? Okay. Well, we don't have any numbers. What's the average value of a head and a tail? I don't know. No idea. Especially a weighted coin, right? So a random variable is a number, a variable, not a number, a variable that associates a number with the event that the coin turns up tails and another number, possibly the same if we have a whole bunch of different outcomes, right? With heads. Okay? It's that simple. Well, at least to start. Okay? Now, in this example, Liam, it's since it's your coin, what do you want? What value do you want to associate with heads?
What do you mean?
Just give me a number.
Oh, 33.
X is a random variable, and usually we use X for the variable. We can use Y, we can use Z. Technically, we can use anything we want, okay? But X is by far the most common, all right? Notice it's also capitalized. A capital, well, we'll talk about that. So if it's heads, X equals, what do you say, 33, Liam?
Yeah, 33.
Okay. And if it's tails?
If it's tails, 123. Sorry, 122.
Okay. That's our random variable. Okay. Now, the way we would write this in tabular form is oh, never mind.
What does What does RU mean?
Random variable.
Oh, it's a V. Got it.
Okay. Now, do you see, gentlemen, that this is our sample space? Okay. We can't find the average value of X at this time. Do you see that? We don't know the probability of a heads. We don't know the probability of a tails. We need to know that to find the random variable. Or I'm sorry, to find the average value or the mean of the random variable. Okay, you ready to roll on that?
Yes.
Can I get
Yeah.
rid of our definition?
I'm good.
Everybody good? Yes, no?
Yeah, I'm good.
Okay. Before I erase it, now that a couple thoughts came into my head, okay? Do you remember when at the beginning of the semester, we were gathering a whole bunch of data and we're talking about a whole bunch of different characteristics, right? We talked about a vote for Al Gore or a vote for George W. Bush in the 2000 Florida election, right?
Mhm.
Well, those are events. You pick any. It's a statistics problem. You take a randomly selected voter from whatever state. We talked about Florida. So from the state of Florida, and we have basically two outcomes, really: a Bush for Gore, or a Bush, maybe three outcomes: a Bush for Gore, a vote for Gore, a vote for Bush, or a vote for somebody else, right? Well, we could attach. Okay, time out. What was the average? What was the mean value of that vote? Really? How do we find that? We don't have numerical data, so how can we find the mean value? Well, random variables allow us to do that. Do you see that? Random variables allow us to find statistics on categorical, i.e., non-numerical data. Do you see that?
It kind of turns them into a numerical.
Because of the rule, right?
Yeah.
The rule associates a number with each outcome, right? So I don't remember, but we might have taken. I know we took data on the number of thousands of miles, so that's already numerical data. Okay. Did we also take, like, do you drive a Chevy or a Honda or a Toyota or a Dodge?
We talked about it, but we didn't
We
do
talked
it.
about it. Okay. So what's the average value? What's the mean value of the manufacturer of your car? Well, how do you do that? Well, you'd have to assign a number to each manufacturer, right? A rule. Again, categorical data now can be statistics can be found based on that categorical data. Eye color, hair color, majors, college majors of a randomly selected student. What's the mean value of the college major? What kind of question is that? So random variables give us a way to further analyze data than just simple probability. Probability that a randomly selected car is a Chevy, for example. Okay. Does everybody see that?
Yes.
Okay. So I'm going to get rid of the definition. Okay, guys? And we're gonna do some examples here. Sound good?
Yes.
Here we go. We said Liam, right?
Yeah.
Liam has a weighted coin such that, and I don't remember what the symbol for such that is. Is it just the line?
I don't know.
Okay. Yeah, that looked kind of weird in a sentence, I think. Such that. Okay, Liam, probability of a heads is what?
Is this something I just get to make up?
Oh yeah, of course. You're the dude who's spending the time in his garage, filing the coin and drilling, milling out a little bit of area here and a little bit of material over there. Yeah,
Sick.
you're
All right.
making the coin.
Probability of a heads is 67%.
Can we say 2/3 to make the math easy?
Yeah. Yeah, sure.
2/3
So
and 1/3.
66% then, yeah.
Okay, so
And
2/3.
33%.
Yeah, probability of a tails is 1/3. Liam, you have been a busy man. I think you'd have to hog out a lot of material or add a lot of material to make, anyway. So,
I wonder if the coin would even look.
I'm sorry.
I was gonna say, I wonder if the coin would even look legitimate after that.
Well, I don't know. Maybe your philosophy is go big or go home. Yeah, probably. I'm a little bit worried that we're discussing how to be a con man. Chris's wife is gonna. So what'd you learn in statistics today? Well, I learned how to weight a coin so it's unfair and I can make a lot of money off a lot of suckers. I don't know, Chris. If you told her that, what would she say?
Say, don't get caught.
So the way we do this, guys, the way we write. Well, okay. Let's take a step back. I'm getting a little bit ahead of myself. For discrete random variables. Is this a discrete random variable, by the way? Is X discrete? Or is it continuous? Remember? Well, careful. How many values can X take on? How many values can X equal?
2.
In total. 2, right? It can never be anything but these two values, right? Does that fit the definition for discreteness? Is it a finite number of values between two bounds? And those bounds for n of variables are negative infinity and plus infinity. Is there a finite number? Well, yeah, it's 2. That's finite. Now, the other one is, can it be represented by an infinite sequence? Well, we don't even need a sequence for this. So do you see that X is totally discrete? Okay. So for a discrete random variable, the probability and it's called a distribution, actually. We can define that or use that term. The probability distribution is given frequently as a table. So I hope it's a little bit obvious to you that you can see these numbers being given as a table with rows and columns. I hope you can kind of picture that. The table looks like this. We have X, values of X, and values for the probability distribution function for the random variable. Probability distribution function. F of X is a function. It is a function of the random variable X. Okay? Now the table tells us how the total probability, which equals 1, correct? Everything all adds up to 1. You buy that?
Hmm.
Talk to me, guys. Does everybody buy that? Everything has to add up to 1, right? What are the values of X? Liam gave them to us, right? 33 and 122, right? For X being 33, what's the probability that it's 33?
2/3.
2/3. Does everybody see where Brian got that answer? It's 33. If a coin turns up heads, probability of heads is 2/3, right? So what's the probability that it's 122? 1/3. And this is the probability density function. This is its definition. Okay. Yep. Yes. Yeah. It's a way to neatly organize it. Okay. Now, let's see. Let me give you some. Formulas, okay? And we'll take it from there, okay? Can I get rid of the Venn diagram?
Yeah.
And actually, guys, I can get rid of everything but the table, can't I?
Right.
Do you see that? Does everybody see that? I can get rid of everything but the table because this table captures everything on the board. Do you see that? Does everybody see that? Okay. Now, I hope it's obvious that we have to know what X is, right? But other than that, we can get rid of everything on the board because this table captures it all. Do you see why we use tables? It's a really nice, neat, succinct way of capturing all of this information. All right. Right now, I'm just going to get rid of this, okay? I can do that. Yes, no? Yes, no?
Yes.
Now, the mean value of a random variable. Mu sub capital X equals the summation of x f of x over all x. Okay. And this is for X discrete. Mu sub X equals what do you think we have to do to find the mean value of X if X is a continuous random variable? Yeah, to find the mean value. Well,
You'd have to do an integral.
for X being discrete, right? We would have the example we just did, right? This was 2/3, yes, no? This is 1/3, right? Right? So to find the average value, what we're doing is we're finding the area of this rectangle, adding it to the area of this rectangle, yes, no?
Mhm.
That's what this does. So think in terms of continuous. What if f of x looks like this? What's the average value? How do you find it? You said it, Brian.
You have
It's
to do
the
an integral.
integral of,
Whatever your range is.
okay, limits, right?
Yeah.
Here we go. I've tried to, and from this point on, we're definitely going to stick to our guns. For discrete and continuous, the major difference is, do you sum or do you integrate? Pretty much everything else is the same. Okay, so it's x f of x dx. That is the mean value for x continuous. Okay, you buy that?
Mhm.
Liam will sell you a couple of flips of the coin. All right. What's the mean value of Liam's coin? Or I should say of X. Liam set the values of X. Guys, it's right. Do you see that it's 33 times 2/3 plus 122 times 1/3? What do you get?
I thought I said 60.
60. Did anyone hear a 60?
No, I thought I said 63, not 33 for the value of
Oh, I'm
X.
sorry. Did you? I'm
I
sorry.
think so.
I'm sorry. Okay, I misheard you then, obviously. 63. Where else? 63, right? And this is a 63. Okay. Okay. So again, what do you get? This is going to be 42 plus 40 and change, right? 40 and 2/3. Yes, no? You buy that?
Yeah, that's what I got.
Okay. Yeah, I asked Liam for him. Well, Liam theoretically calculated these. Maybe this is the amount of money that he pays out to a poor sucker. That see, you should have kept this at 33 if that's the case, Liam.
Yeah,
Anyway,
true.
so like if he pays out 63 cents, if it turns up, this was heads, right? Right. So Liam pays out 63 cents if it turns up heads. He pays out $1.22, 122 cents if it turns up tails. Pretend, right? Right? So how much is the average payout? 82 and 2/3 cents, right? So if Liam charges $1 a coin flip, he's going to make on the average, right? No, well, no, this is the payout. So he's
You
going to get
subtract that
on
from the
the,
dollar.
yeah, exactly. So he's going to get 17 and a third cents on the average. So if he gets 100 suckers lining up at a stall that are too stupid to see the coins weighted, he's going to make 17 bucks and change, right?
You eat like a king at McDonald's.
Do you want to, let's see, what do you guys want to do? Do you want to move on to another example that's a little bit more involved, or do you want to do something like rolling a die? Because all of these concepts work for something as simple as rolling a fair six-sided die as well. What do you want to do? Okay, a simple one or a more complex one? A little bit more involved. Okay, let's do that. Can I reboot the board?
Yeah.
Okay. Okay, let's roll a fair-sided die so we can see that the math works. I'm going to switch to black because I have the most black markers. Okay. Clearly, the sample space is 1, 2, 3, 4, 5, and 6. You ever wonder how come why a die isn't zero indexed? You ever wonder that? Yeah, 0 to 5. I mean, wouldn't that be more? Anyway, I get all these wonderful ideas that probably will never catch on. So, if X is simply the number that turns up on the die, then the probability density function or distribution function, it's called a PDF, by the way. The PDF looks like this. What's the probability of 1, guys?
This is a fair die.
Yes.
1/6 for each.
Yes, no? What's the mean value? One to 6, yes, no? That's all X, right? Right, guys?
Mhm.
And f of x is 1/6 everywhere. So we can just write 1/6, right? Because it does not change, right? For every single one of those 6 values, it's the same, 1/6. So guys, it's the same. We worked this problem out probably a month ago or more, right? This goes to if you add up all the numbers and divide them by 6. If you add up all the numbers 1 to 6, you get 21 over 6, which is 3.5, which is exactly what we got when we did it, whenever we did it originally. Does that make sense? The math works. Yes, no?
Mhm.
Okay. How much time we got?
24
Okay, a few
minutes.
Yeah, okay. Another example, guys?
Sure.
Can I can put the other example. Can I get rid of this from the
Yeah.
previous problem? Going once, twice. Okay. Now, let's. Do you want to use Liam's coin, or do you want to use a fair coin in this next example?
No preference.
Guys, it's not a trick question. Just give me one or the other. Okay. Now with Liam's coin, probability of a heads equals 2/3. Yes, no? Right?
Yeah.
Okay. Okay. So we flip Liam's coin 3 times. X equals the number of heads in the 3 flips. Where did I come up with that? I just thought actually it's written in my notes, but anyway. Okay. So we can have some fun with this. Okay. This marker is rapidly dying. Let me switch to this flavor of blue. So, number A. I assume you can read the blue rather well. Find the domain of X. X can't only take on a few values. Okay, it can't take on, an infinite number of values. So we got to figure out what they are. Okay. Number B, determine f of x. Okay. Number C. Okay. You know what? Let's go for Baroque. Okay. Find the probability. Let me write it in probability form like I should. Probability that x equals 1 or x equals 2. Number D, find the cumulative function, which I have not defined for you yet, but I will. Does cumulative have 1 m or 2? I think it's 1. Distribution function. F of x. I will show you what what number D is all about, guys. I will. Okay. So it looks like we got a little bit of work to do, huh? Can I get rid of our fair coin thing? Fair coin example?
Yeah.
Oh,
The fair
okay.
die.
Yeah, that's what I meant. So what's going to happen? Evidently, people are onto Liam's, flip a coin for $1 and I pay 63 cents or whatever it was. So Liam has to change his game. Okay. So he flips the coin 3 times. Okay. And X is the number of heads in the 3 flips. What can X be? Can X be 0? Can you flip the coin 3 times and have no heads?
Yes.
Sure. Comes up tails all 3 times, right? Can you have 1 heads among the flips?
Mm-hmm.
Can you have 2?
Yep.
Can you have 3?
Yes.
Can you have 4?
No.
You can't have anything greater than 3, correct? This is the domain, guys. Okay? That's the domain. These are the values of X. Now we have to find the probability 0, probability 1, probability 2, probability 3. Okay? Are you ready to roll?
Yes.
What's the probability that X equals 0? Well, there's only one way to do this, right? Talk to me.
You have to have tails come up 3 times.
Do you see that, guys? And by the way, this goes back to what we started with earlier, guys. This goes back to what we started the conversation with. My knee has been killing me all day. I have to sit down. Sorry, guys. I get a new one on December 27th.
You excited?
I'm not looking forward to the pain, but maybe it'll be better than the pain I've been having, huh?
Yeah.
That's a good question.
You should ask them if you can just keep the old one.
Yeah, can I keep the old one like in a jar?
Ew.
Or like
What-
they
what-
clean it up and put it in like a display case on like a stand.
Yeah. I mean, it's mine, right?
It'd be
Why
it'd
should-
be a nice conversation piece to put on your mantle or something.
Well, my wife, she got in a pretty bad car accident back in 2013, and she shattered her heel bone. Okay, and it was shattered into 4 large pieces plus a whole bunch of little pieces that they had to remove. Anyway, in case you're wondering, it's called the calcaneus. That's what your heel bone is called. And it's the strongest bone in the body. It's the hardest bone in the body. It's not the biggest, obviously, but it's the hardest, which makes sense because
Harder
when
than
you're
the
walking,
thumb?
standing, running, whatever, right? It bears the weight of your whole body.
Hmm.
So it has to be the hardest, right? So anyway, it went in 4, and she had to have surgery, and they put the thing back together, and they had to put screws in to hold it together while it healed, right? Right. So I think she had 4 screws. She had 2 titanium and 2 stainless screws in her foot. And, I told the guys at work, what was going on. And I was in, Chris, I was talking about the space simulation area that I was in earlier. And that's where I was working back then. And I absolutely love those guys. We were just a bunch of hillbillies back there. We all lived in the country. We all had a tractor, usually more than one. We loved being outside, working with our hands, that kind of thing, right? So George goes, really? She's got a couple titanium screws and a couple of stainless screws in her heel? I said, yeah. Just, wow, her scrap value just skyrocketed. So, man, George, you're right. So, a couple of the screws were causing her problems a couple years later, so they went back in there and took them out. And man, I insisted that I get those screws because I need to preserve my wife's scrap value. Okay, so anyway, okay, go on. That can be a dangerous occupation. Trust me. Yep. Yeah, that can backfire on you real fast. Did he have to have surgery? Oh man, that's surgery. No. Well, he was fortunate, really. He was actually very fortunate. Yeah. So back to our problem, guys, so we can finish it up. What's the probability of 3 tails, guys? That's where I was going. Do you see, guys, that the event that the first flip lands on heads doesn't affect what the second flip turns up to be? Do you see that?
Mm-hmm.
Which doesn't affect the third, right? So they are indeed independent flips. Do you see that?
Yes.
The probability that the first flip is a tails doesn't affect the probability of the second, right? Or the third. So therefore, they're all independent. So like we said before, with independent outcomes, we just simply multiply the probabilities of the outcomes together to get the probability of the event that it's 3 tails, right? So it's what's the probability of a single tail? Isn't it 1/3? Right? You flip, Liam flips it once, the probability that it's tails is 1/3, isn't it?
Yeah.
So
Yeah.
what's the probability the second one's a tail?
1/3.
And the third?
1/3.
So probability x equals 0 is 1 out of 27, is it not?
That's what I get.
Okay. Are there any questions on how we got that, guys? Let's move on to hearing nothing. Let's move on to probability that x equals 1. What is probability x equals 1? Well, it's the probability that we have two tails and one heads, right? Yes, no?
Correct.
So that's going to be the probability of tails, heads, right? You buy that?
Yes.
I don't. Are there any other ways that x can be 1?
Well, yeah, you can rearrange the order, but it doesn't come out the same. Oh, it doesn't come out the same.
Right. We got off easy with 3 tails because there's only one way to do it. Here, there's 2 ways to do it, and actually it's a permutation, guys. But there's 3 ways to get 1 heads. The last one can be a head, the middle one can be a heads, or the first one can be a heads. Do you see that?
Yeah.
Now, luckily, these probabilities are all the same once we multiply them out. Tails is 1/3, tails is 1/3, heads is 2/3. And it's going to be the same for each one. The individual probabilities are just going to be rearranged, right? But we're still going to get 2 out of 27 for each one. Yes, no?
Yeah.
And we have 3 of them, so it's 6 out of 27. Do you see that, guys? Does everybody see that? Or alternatively, does anyone not see that? This is where the waters get a little bit dicey, okay? You have to understand what's going on. So do you see the probability x equals 1 is 6 out of 27?
Yes.
Does anyone not see that? Does anyone need another explanation? Okay, that's what we're going to roll with. Buy that? Okay. Ready to move on to x equal 2?
Yes.
Isn't this the probability of 2? Let's keep it in tails, heads. 1 tails and 2 heads. Yes, no?
Mm-hmm.
Well, how many ways is there to do this one?
Also 3 ways.
3.
3 ways, right? 3. First one can be tails. Last 2 can be heads. Middle one can be tails. The other 2, right? So it's 3 times. We need a tails, and we need a heads, and we need a heads, right? 3 ways to do this. You just rearrange where the 1/3 is. That's all. And 12 out of 27. Help me out.
Yes.
By the way, gentlemen, there is a reason I am not reducing the fractions. It just makes adding stuff up easier, doesn't it?
Yeah.
What's the probability x equals 3?
That's 3 heads.
How many ways are there to do it?
Just 1.
1. So it's 1 times 2/3 times 2/3 times 2/3. I get 8/27 out of that bad boy. Yes, no?
Yeah.
Okay. Are there any questions on what we did, guys? Talk to me. This is number B, is it not?
Yeah. That's kind of weird that you're more likely to get 3 heads than just 1 head.
Well, think about it. It's weighted pretty heavily, right?
Right. It's just kind of weird to see it.
It is. It is. Yep. How do we know that it has a chance of being right? We don't know for sure it's right. Well, we do, but as a really quick sanity check, what's the easiest thing to do?
The bottom row adds up to 1.
Is that true? Is that
Yes.
correct? Yeah, it certainly does add up to 1. Do you see why I kept the 27 downstairs?
Mhm.
The numerators, if they add up to 27, we're good because they're all divided by 27. 27 over 27 is, of course, 1. So they do add up to 1. So if we didn't know what we were doing, we would at least have a fighting chance that this was correct. Okay? If they didn't add up to 1, we would know that it's not. Okay? I think we can do number C, and then we're probably going to have to call it a day. Or, well, I don't know. How do we do number C, guys?
Can you just add up the probabilities?
That's all you do. Oh, I didn't find mu. I meant to find mu. So this is going to be, this is C1, okay? C sub 1. What do you get? I get 18 out of 27, which is 2/3, if you want to reduce. Okay, now let's find mu. Well, first off, are there any questions on this?
No.
I meant to find mu. I don't know why I forgot about it. Okay, let's find mu. I'll go down to the bottom right corner of the board. That's clear for you guys, right?
Can you write on it real quick? Yeah, that's good.
So C2. Mu sub x is the summation of x f of x. Yes, no?
Uh-huh.
That's what we said. So this is going to be, the values of x are up there, 0, 1, 2, and 3, right? So it's 0 times, well, I can do this one in my head, right? Yes, no? Plus, what do I write next, guys? I'll spot you the 1.
6 over 27.
I can do that in my head too. Plus,
2 times 12 over 27.
what do you get? 6, 24, that's
over
30,
27.
54 over 27?
Yeah. Which is 2.
Average values 2. Does that make sense from our table? I mean, does that kind of match your gut?
Kinda, yeah. It's the most common.
Not too far from half of the probability distribution is right at 2 anyway. So it should be right around there, shouldn't it? So, yeah. Okay. We finished everything but D. And we're just out of time. So we'll pick it up on D on Tuesday. Okay, guys? This stuff will not be on your opportunity. Okay? Anything chapter 3 wise with random variables, this won't be on your opportunity. It'll be on the next one. All right, guys?